Alright guys, so the second to last video will be finding the inverse of a matrix. So remember before you did how to find the adjoint of a matrix and the determinant. So if you guys didn't check out those videos, I'd urge you to check them out before you start this video. Alright, so assuming you watched the videos before, let's continue. So the inverse of a matrix named A is written as A inverse. That's a negative one on top of it. So A inverse. That's the notation for it. Alright. And the equation for it is given right here. So A inverse is equal to 1 over the determinant of A, which you should know to find already, multiplied by the adjoint of A, which we did in the previous videos, okay? So that's the general equation. To find the inverse, you need the determinant and the adjoint. Fair enough. So let's try some examples. So the first one, let's look to find the inverse of this here. So the equation is 1 over the determinant multiplied by the adjoint of A. So the first thing we need is the determinant. So remember the determinants are A. Like when you corner determinants are A, that's equal to A, D minus B, C. So if we go up, this will be A, B, C, and D. So this will be A by D, which is 3 by 2, which is 6, minus B by C, 4 minus 4 by 1 is 4. So the determinant will be 2. So you go up here, so now we know the determinants are A will be 2. So the next thing we need is the adjoint. So the adjoint of A, remember that is, so the first thing you do, you interchange A and D. So this will be 2 and 3. And it's probably signs are B and C. So B will become negative 1 and C will become negative 4. Alright, so then you go back here. Alright, 16. So we have 2, negative 1, negative 4, and 3. Alright, and you just expand out the half from outside, and you basically just multiply the half by each element in the matrix. So a half by 2 will be 1, a half by negative 1 will be negative a half by minus 4 will be minus 2, and a half by 3 will be 3 and 2. Okay, and that's the answer there. Alright, one more. So same concept. So this will equal to the B inverse. There's 1 over the determinant of B multiplied by the adjoint of B. So let's see if we could find. So we have the determinant of B, AD minus BC. So we go, so this will be A, B, C, D. So A by D is 6 4s are 24. Subtract B by C, 8 by 3 was 24. Alright, so you notice this will be 0. So this is a singular matrix. So the rule states that any singular matrix does not have an inverse. And you can clearly see, because if I put the determinant of B into this, to 0, this entire thing will go to 0. So therefore, the law states any singular matrix doesn't have an inverse. So always remember that once you see the determinant is equal to 0, it wouldn't have an inverse. So that's a little side note. Alright, so if we were to change this 4 to, let's say, 2, it should work out now. So 6 by 2, the A by D. So that's over the inverse, the determinant. So A by D, now 6 by 2 is 12. Minus B by C will be 24. So the determinant will be negative 12. Okay, so now we have a non-singular matrix which has an inverse. So the next thing we need to get the inverse is the adjoint. So you swap A and D, so 2 and 6. And you change the signs of B and C. So since B is positive, you get negative. B is positive 8, C is positive 8, sorry, be negative 8. And that'll be at the adjoint. So Now I can erase this 0 here because we solve a negative 12, and now we have the adjoint of B. She just calculates right there. So let's plug it in. 2, negative 3, negative 8, and 6. And just like we did before, we just multiply it out. So negative 112 by 2 will be negative 1 on 6. Negative 112 by 3 will be 1 on 4. Negative 112 by 8, 2 on 3, so it'll be 2/3. And then negative 112 by 6 will be negative a half. And that will be the inverse. Alright, so and with that said, that's the end of finding the inverse of a 2 by 2 matrix.